Okay, so the plan for today is to implement image processing by using filters and this type of kernel. And the idea is let's try to implement it linearly. So by just using the formula, then we can try to optimize it by using pthreads and finally by using CUDA, and then do like a benchmark and see what speed up we get from each alternative. To not waste that much time on reading the images from file, let's use this STB Image Library, and this makes things pretty easy because we just have to provide the file name to the image and we get the bytes from that image. So it like handles all types of extensions. So yeah, we don't have to care about whether it's a PNG or a JPEG. And yeah, let me double get this file. So let's take the raw link. Okay, now we have this file, and sure, let's begin by doing a C stdio. Okay, so great. We need an image to test with, and I think I'm just gonna use this one because it's small enough to not take that much time, but after that we'll take like a larger image to see the time difference. So I think we can just double get this. Let's see. Yeah, I'm not even sure what this animal is. Looks like a mouse. Okay. So yeah, we'll try to take some filters from here. There's also like an algorithm for GLSL, but I mean, yeah, basically this is the algorithm, but like this is what we are gonna use for implementing the linear version, and for implementing, I guess, using pthreads, we'll do it with pthreads. We'll put one row on one thread or something like that, or we'll split the image into chunks like multiple rows on one thread. Okay, so to use STB image, we have to do this. We have to define STB image implementation and then include it. And yeah, let's actually also use my argparse.h. Yeah, of course we need to download this. So wget, and then we need to add it. And yeah, basically I was thinking that maybe we can have like the call to the script be something like -I is input dot whatever. We give it -O for the output, and maybe for filters we can have like blur, maybe like a list of filters to apply on top of the image if you want to do multiple, or just one if you want to do one. Right, like let's keep it like this. Okay, so let's say we have these arguments, right? Maybe something I need to add in this readme is an example to copy paste it, right? But I mean it in main.c. So let's say we have the argument parser, image filter. Let's call it like basic implementation. Okay, let's put the v and h things. Now let's have I for input, the input file, name, this will be a value. Then we're gonna have O for output, and F for filter name. Then let's not forget, because last time I used it, I forgot about the argc and argv. Okay, and then I mean let's just get the values, right? I mean we can also just do help, and if we get we just exit. The same for version, and then let's have here input, output, and filter. Yeah, I was thinking let's make these like required for now. Maybe in the future we'll print and read from standard input, but not really sure. So if yeah, let's do it like this. So now we can read the image. Let's see. I mean we can just use STB load. Oh, it was like an example. Yeah, so let's take a look. So we're gonna have the bytes of the image, and yeah, this is the file name, so it's gonna be input. Then we need the width, height, and the number of channels, and how many channels we want to read. So let's say we do here define num channels 3, right? Num channels. And now we're gonna have a width, height, and channels. We put the address of the width, the address of the height, and channels. So now let's printf these things. It's like basically if you run file on this, right, you get the same information. I mean even more information, but oh yeah, we need like to include LM, I think, because it has some references to some math functions. Anyway, so I need the input, which is going to be this image. Let's call it something else, like blur.png, and for the filter let's use blur, but I mean you get the idea. So it gives us the width, the height, and the number of channels. And yeah, now let's have here why not even maybe create a structure for the image, right? Like struct image and have all this stuff in it, right? Let's have I was thinking about something like this, but like have a wrapper around that. I mean, it would be nice, wouldn't it? And then let's have a free image, which, oh, yeah, I didn't know it has free. That's interesting. Okay, anyway, so let's now change this stuff with structure image. Okay, and then at the end, let's let's arg parse free, and then I would also say free image. Like whatever, it didn't work. Maybe you should handle, so let's say, oopsie, so here if image equals null, and here if image bytes are null, then free image, right? Like this is how you should do it. And here if maybe something like fprintf, something, and then here we can do the stuff. So let's say so if we try to apply a filter, right, we should have a copy of the image. We don't want it to let's see here, for example, when they show this kind of algorithm. Output image pixel. This is interesting. I mean, I would say that you kind of need a copy of the image, because otherwise you are gonna overwrite the original image, and like depending on the filter you might read a changed pixel. So yeah, so let's have here maybe a void. Like, sure, fair enough, we can also have save image, STB save. Well, let's not go there yet. Well, is it like this? No. Anyway, let's see. So we want to apply a filter, right? So let's say we want to return the apply kernel. So here we need the image, and I would say yeah, like this makes sense, because like all the kernels are square, more or less, in this thing. So we're gonna have a float pointer kernel and the kernel size. Okay, it somehow, I think it knows that it has to, wow, it like did everything. Yeah, I mean, I would prefer to okay, maybe let's have a function struct image pointer new image, and let's say we give it the sizes, right? So it has to allocate the image structure, then it sets the fields, it allocates the time size of this thing, just in case it's not one, but it is one because it's unsigned char. Then we do basically the same thing as we did here. So now we can have a struct image new image, we allocate the new image, and at the end we return new image. What might be interesting is, do we free the old image or do we not free it? I mean, I guess it's not really important. We can free it outside. Like, it makes sense that this function returns a new image, right? And it's not done in place. Although we can also do it in place, but yeah. like maybe for some reason you want to keep the old image in the code. So let's leave it like this. Okay, so now we just have to follow this algorithm, right? So for okay, and now let's use x and go until the width of the image, and now basically we have to create an accumulator. So let's do basically let's use a float for the accumulator, because here we have float. So let's have a float. Oh well, yeah, it's right, because we also need to iterate the channels, right? So we are gonna apply the same filter on all channels, why not? And like, let's say the number of input channels will be the same as the number of output channels. We don't do any average or sum on the channels, we just leave them as they are. Okay, so now let's have a float accumulator. Let's call it accumulator. And now we should go through the kernel size plus plus and kernel x. Perfect. So now let's think about it. I would say to keep things simple. I mean, because in convolution you have to flip the kernel, but does it really matter when it's the same? Like it's okay, so I'm not sure what W is. W is the filter kernel. Okay. So the interesting thing is that probably I would start. Well, yeah, let's start from zero. Like it's okay. So now we need like the x and the y coordinates from where we read from the image, right? So int image x, we need to do x, we need to offset it by kernel size divided by 2. Like maybe it would make sense to showcase that. So let's say if we have the image anyway like this, let's say, yeah, and let's say the kernel size is 3. We have a kernel like this, right? And maybe we are in this pixel, we want to filter this pixel, so we need the pixels around it, right? So kernel size divided by 2 will be 1, so we need to move 1 in both directions, up and there. But let's say for now, just for x, we need to move like this once, and then when we add kx, we'll have this one, and this one. And for y, int image y is gonna be the same thing. It's gonna be up once, and then we're gonna have all these things, right? And now the question is, so say we do x minus I and y minus j, so it would be easier to do it the other way around, I guess. So usually you would multiply this, I think, with this, and then this one. So let me just put once, 1, then 2, I think with this, something like this, right? Like you go in the reverse order for some reason. It works better, but as I said, like these are the same everywhere, so it's not really important. But yeah, I mean, let's do it like this. Okay, so let's have another function that gets the value from x and y. So should be STB I get pixel, and we give it the x and y where we want to get a pixel. We should have something like, if this happens, we return a 0, right? So yeah, like if we wanted to apply the kernel on this pixel, we would have these 4 pixels that are outside of the image. So what are we gonna do about them? And one idea is to either ignore them, like set them to 0, wrap the image around or something, but like the easiest thing is to set them to 0, and imagine that we have a padding of zeros around the image infinitely, like something like that. So yeah, let's have this get pixel. So basically we need to get a pixel, and here um okay, let's think, because I would like to well, I mean, the easiest thing is to have here like kernel size, right, like minus k y minus 1, and this would make it let's say in the reverse order, like the image would be sampled let's delete that. 1, 2, 3, and the kernel would be sample like 1, 2, 3 like this, which is the same thing as if we do it the other way. It's gonna be like 4, 5, 6, and here 4, 5, 6. So yeah, pretty much the same thing. Okay, so now we have the accumulator. And here we can set the value. So we convert it to unassigned character. And yeah, we set the new image to have this value. Basically, that's it for applying the kernel. So let's try to now have a function to save the image. Save image. Okay, let's see if there is something like right. More towards the start. I mean, I would be surprised if there's no right. Save. I mean, that's yeah, I mean, probably we would have to implement that then. So let's give this the image and the file name. Should we do like PNG? So we have the file header. Because I would like to see like an example. Let's say, I mean, it's the PNG signature like this, the header, I data, and I end. Well, maybe we can find, like, let's say simple image format. Mm, like PGM or something. P or PBM. Because I would like to have, so it's PGM for grayscale and pixmap P6, because yeah, basically I would like to have like the header P6, then the width and the height, I think, and then just the bytes, right? So yeah, was it like the size, the maximum value, and then just the values themselves, right? Something like this. Okay, let's just say like file, write binary, okay, then say like there's no right. Okay, so then we want to fprintf into the file. We want to show this stuff, and then we want to write all the bytes into the file. And I think it's like the pointer, the size, so it should be maybe like size of STBIUC, then this stuff, and then at the end the file, and then we want to fclose. So what if we define some filters or something? Blur kernel size, and then blur kernel. I mean the blur kernel is, let's say, box blur, or I mean, sure, fair enough, Gaussian blur. I have no idea. Anyway, so we have the thing. But let's just apply. Um, let's apply the kernel. Hmm, interesting. And at the end, let's just save the image. So what we can't say that. What if we specify something like this? Still doesn't. Hmm. Anyway. I mean, why float pointer kernel, or like, yeah, like, why wouldn't it work though? Anyway, let's try to compile this thing, and to be honest, we can open both of them. So I thought you can you can like scroll through them, but yeah, let's go into image filter, open. I mean, we open them in. Yeah, like, does it look changed? To me, it looks a bit changed. We could also take this image and like compare it. Yeah, like, to be fair, it looks blurred, right? I would say. Yeah, so that's pretty good. I mean, here we set PNG, but it's actually the, like, if we look with file vd blur, it will say that it's a pixmapnet PNB image. But yeah, it doesn't matter, like, GIMP can open and display anything, so it's fine. So yeah, this is basically the implementation of just, like, let's say, a simple filter. To be fair, I would like to change some stuff here, like refactor the code a bit, and think of how can we, like, let's maybe create a function for getting the filter. And for filters, I would say we also need a structure, like struct kernel. We need the size and the values. and we might need struct kernel, new kernel, and let's say const char pointer name. And maybe something like this. We need to alloc. I'm not sure what's the problem with expected expression and stuff. Like, honestly, we can just create a for loop and just Okay, let's make kernel and let's copy it like this. Because I was not really sure. And then we can have a free kernel. And here let's say struct kernel k, k size, k size, well, k size again. And whatever k size. I was thinking of having like get kernel get pixel or something. But yeah, so let's create struct kernel k equals new kernel, and here we pass the k, save the image, free the kernel. Now if we compile it, if we say like this, it's gonna fail. So yeah, that's good. Basically this is the implementation for applying filter linearly. So we get, this is from the Wikipedia article and pretty much looks the same. Now yeah, we should probably try to get a diff between them, but yeah, let's say that the linear application will be the baseline, and we'll compare the other ones with it, and then we compare the speed of the other implementations. So yeah, see you when I will implement the P3 version.